So here we are, once again, Grumpy Science, Mark Tommerdahl, Bob Dennis.
And once again, we're totally unprepared because we have no idea what to do.
Completely. So we're gonna talk about some a comment that you got.
Yeah, we got a comment on. By the way, we'll just go ahead and mention that we have sort of, I guess, would you say we partnered with Self-Hacked right now?
Oh yeah, that's right.
So
we're working with Joseph Cohen on Self-Hacked because he's very interested in using our stuff to try to help people self-experiment, find their way from wherever they are to a healthier place.
They're very big on biohacking and promoting better health, and in this case, better brain health. And we are, I guess, BrainGauge is probably the only game in town as far as a biohacking tool for easily measuring changes to brain health.
Accurately.
Changes to brain health. So actually, we have a laboratory-grade device.
I'll sell you something if you want.
Okay.
So
we like to think we do actually have a laboratory-grade device crammed inside this a container that's shaped like a computer mouse. And it's,
whatever you do, don't eat it.
Yep.
Here it is. It looks just like this. Even though it looks like a tasty lozenge, don't eat it. So yeah, Joseph Cohen has recently, on Self-Hacked, has recently started working with us on that. But full disclosure, you know, at Micro-Pulse, we've been working with Joseph for 2 or 3 years already, and he promotes our stuff, and largely he'll spend a lot of time explaining, you know, in different comments and blogs and stuff, how to use the Micro-Pulse stuff for all kinds of things that I don't know anything about.
And some people might even find this video from Self-Hacked, which is sort of like one of those recurring loops.
It's one of these recursive things, yes. Like maybe we should put mirrors behind us so you see like a million.
Or the
funniest.
I have a funny story on recursive loops.
There is such a thing as a funny story.
Nah. I thought it was funny. It's sort of a mind blower, but anyway, it always blew my mind. This was 25 years ago, I guess. Because I was early in the optical imaging game, cortex as it was responding at very high resolution. And the leaders in this field were actually a group in Israel. And the students there, they were doing visual experiments where they, so the visual experiments means you like, well, here, we'll use our multimedia thing. They would, in front of the monkey, they put some kind of visual stimulus in front of the monkey. And in response to that, they would measure the brain activity in visual cortex.
They would, was it the optically measure it?
Optically measure it.
So actually they're taking really high resolution, like pictures of the surface of the cortex, and you can actually see.
You can actually see changes.
Which I find quite interesting.
So you sweep something across the picture in front of the animal, in front of the monkey or human or whoever was sitting there watching it, and then you could see things happen in the cortex, happen in the brain. Pretty cool. Well, the grad students that were doing this, you know, you always have these late at night experiments. We don't do this anymore because late at night experiments aren't allowed. But
that's when science used to happen.
The good stuff used to happen. Well, what they did was they put up the first image for the monkey to look at, and then they imaged what the monkey was seeing in his brain, and then they took that image and put it in front. And so now what the monkey was seeing was what the monkey was seeing.
Basically looking at his own visual cortex. Right? How cool is that?
So and whether it changed or not was responsive to what it was.
Right.
Totally unpublishable, but a really cool experiment to think about.
Okay, well, that's, I mean, you know, interesting things like that. And it would be interesting, you know, does that even make sense? I mean, is something on your visual cortex, you know, laid out on a surface of your visual cortex? Is that something that would even register as a pattern that your brain should recognize? That's very self-referencing for the brain function. Yeah, exactly. We talk about introspection. That's literally introspection. Looking at your own cortex while you're thinking. Okay, yeah, that's creepy but funny.
Creepy but funny. Think about it.
I guess high marks on the creepiness scale. There's a thumbs up if you thought that was creepy enough to be, you know, science funny.
Yeah, right? So on the creepy scale, I guess we're done.
Okay, so we're done with creepiness.
See you next week.
Right, exactly. So Mark wanted to, first of all, he wanted to make fun of me for my non-beer beer. That's fine. I'm just going to put it out there. He just doesn't think it's manly enough.
Well, he ran out of beer, so now he's back to drinking.
I had to reach the very back of the fridge today.
Okay.
So Mark was going to talk a little bit about heart rate variability.
Right, and this came up
HRV. People talk about this all the time. And?
Well, there was some content on self-hack, and one of the viewers of that content put in a comment, and I actually responded to it, but it hadn't popped up yet. But anyway, he basically wanted to know, first of all, question he had was, how often do you need to test with brain gauge to see changes in brain function? And our answer to that is, it depends. Okay, next question. So anyway, it depends on time scale. The time scale is based on what's the time scale of whatever the change is.
Yeah.
I mean, if you're taking a drug that takes 3 hours to take effect, then, well, you should put your time points based on that. If you're taking a drug that's immediate, then you can do before and after, and we've done experiments like that. If you're taking a supplement that might take 2 or 3 weeks to actually alter your brain function, so then you need to test over that time course.
Right, and HRV is something that Mark knows a lot more about it than I do, but is something that has been really studied extensively and had really been published about extensively for a while. And
sure. And his
Mark
question
told me that's kind of settling down now scientifically, but there's a great interest in it among the people sort of on the internet doing self-hacking, right?
Right, and so his other question, besides testing frequency, was about how does this compare to heart rate variability?
How does brain gauge compare?
How does the brain gauge compare to heart rate variability, and should he continue to just monitor his heart rate variability, and does that give him an insight into whether he's getting healthy or not, or should he look at like brain gauge? So I guess my answer.
Yeah. So heart rate variability is measuring what? It's measuring the variability, the rate of your heartbeat. Mm-hmm. That may relate to something going on in your brain, like, for example, pain, sensation of pain. Right?
Okay, so
it may, but it relates to a lot of other things too.
So yeah, So technically, what we study and what we've always been nerdy about is central nervous system. Central nervous system is made up of the brain and the spinal cord. Peripheral nervous system is all the other stuff outside that, except for the enteric nervous system, and we won't get into that. Right. That's in your gut. It's got a mind of its own a lot of times.
Mine does.
Anyway, the autonomic nervous system made up of parts of the peripheral system, and it's influenced by parts of the central nervous system. In other words, you've got your heart rate. When does your heart rate crank up? Well, a gorilla starts chasing you. You're going to process that, get excited, and start running a lot faster, and adrenaline starts pumping. And
so, how fast can your heart rate change?
Pretty dang fast.
Do you know the answer?
No.
A single beat. Do you know how we know that answer?
Nope.
It's a really famous story, which I'm about to tell.
Oh, cool.
So there were these two guys doing something interesting. They were the first two guys flying to the moon, Buzz Aldrin and Neil Armstrong, fully instrumented up, getting ready to land on the moon. And Neil Armstrong's sitting there, and they're, monitoring everything going on the Apollo capsule as it's landing for the first time on the moon. And they have this ground radar that bounces back and tells them what their altitude was. And they're coming in for landing, coming in. And on all the older guys who know about computers are going to get this. All of a sudden, they got a 1202 alarm. Right? Buffer's full. The computer stops working. And they're monitoring the heart rate of both of these astronauts as they're landing. And Neil Armstrong's heart rate went from something like 78 to 184 in one beat. And that's how we know, because we've never been able in a laboratory to actually scare somebody that badly.
Yeah, but it's true. Allowed to do that. No.
We're not allowed to scare the life out of someone. Like, oh my God, I'm about to be the first person to hug a spacecraft into the moon. So yeah, so heart rate variability is a function of a lot of things, right? It's like you can become alarmed, you can coughing, right?
Sure.
Valsalva maneuver. Like this, right?
Yeah. And so
you can have a cold.
Yeah, there's just a little part of the brain is connected to the autonomic nervous system. I mean, it's significant.
But the autonomic
connection.
Nervous system's taken other kinds of inputs that are more somatic too.
Yeah.
Right? So there's all kinds of stuff that are going on.
There is. But if you really want to know about brain health, heart rate variability is really not going to be that sensitive to a subtle change. Like it's probably not changing while I'm sitting here drinking beer.
Not in most of your brain.
It's probably not going to change that much over.
So well, this is true. And one of his questions that he sent to Mark through self-hacked was, are the brain gauge readings less volatile than the HRV readings? So this is kind of getting into the measurement of HRV. So what he means is, do they kind of change a lot? You know, is the brain gauge more stable of a measurement than HRV? And first of all, I think the answer is yes, and it's yes for a couple of reasons. First of all, real heart rate.
The question.
Well, are the brain gauge readings less volatile?
Less volatile. Oh, I was thinking HRV. More volatile.
No. He wants to know, is brain gauge a more stable measure? And I think it's a more stable measure of brain function.
The way you phrase the question. Right?
Yeah, anyway. I was trying to translate it, but basically, I think it is for two reasons. I think brain gauge is more stable. Number one is it's really measuring something about the brain that's kind of real, and HRV is measuring something about the heart that's real. But also, you're measuring it the big way that HRV is measured now is with smartphones, right?
Smartphones.
Yep, and smartwatches and stuff like that. And we've already gone into that. Those are not
about
really
laboratory grade.
They're not laboratory grade
tools before, which the brain gauge is laboratory grade. You told me once about a little study that somebody else did.
This was reported on one of the BBC sort of technology shows, but I've heard it reported 3 or 4 times elsewhere where people, and they don't do this so much anymore because nobody wants you to do this anymore. Because it's such a killjoy thing to do at, like, some big tech expos. You go and I'm from the BBC, can I borrow this watch and wear it around all day? Well, they'll get a person to borrow 3 or 4. I saw a person with 4 smartwatches on, and they reset all of them and started walking around all day, and they were just trying to monitor probably the simplest thing to measure, which is how many steps do you take.
Yeah, I thought it was heart rate variability. So
well, they also do HRV, right? And all 4 of the devices gave totally different measures. Some of them were off by more than 100%. So the guy was sort of trying to count, and he figured he had taken about 2,400 steps, I think, is what I think he had sort of counted in his head. And one of them said, today you have taken 1,200 steps, and that's not nearly enough. And another one of the watches said, you took 10,000 steps today. That's great. So, and they were all sort of all over the map, and the same thing on HRV. So, just because you have a device that gives you a number doesn't mean that it's measuring anything. I mean, I could give you a little LCD display that displays a number for you, 12. Whoa, that's really cool. What's it telling you?
I'd rather have one that says 12.0001.
12.00. It's much more precise.
That's more precise.
Exactly. That's what we're looking for. Is ultra precision.
How accurate is that, though?
So the point here was his question. I think buried in his question about HRV was, do I really need to buy a brain gauge? Can I just kind of measure my HRV because my smartphone already does that?
So anyway, think about this. Yeah, 90% of the brain, or 95%. There is a sliver of the brain that's involved with,
but it's not the only
modulating
thing.
HRV. But it's not the only thing the brain does.
Yeah,
thankfully,
and that's not the only place that HRV gets modulated. And then if you're using a non-laboratory grade measure of it, so if this is a hobby and you just sort of like to see it and everything, that's cool. Go ahead and go for it. But if you really are kind of concerned about your brain health, it's sort of like measuring the wrong thing. I mean, if you want to know, how healthy you are, you don't go weigh another person, you don't make the wrong measurement. And HRV is probably not the right measurement to make for brain health, because there's so many things that do impact the brain and that don't impact the brain, and they're all kind of rolled into one number.
And there's going to be some things that actually impact heart rate variability that don't impact the brain.
And by the way, that number is noisy. It's not. It doesn't tend to be stable.
Yeah.
You've got to be you've got to be under laboratory conditions for HRV.
And I guess one of his questions was how volatile is the brain gauge? Is it going to be like HRV, where he has to measure it at the same time every day, and because when he's really calm and first gets up, or the brain gauge actually will reflect different states. Mm-hmm. And so if you're, because if you're drowsy, it's going to reflect that. If you're highly aroused, it will reflect that. But it's all got to be done in context dependent. It will affect some measures.
If you're just grumpy.
Yeah, if you're grumpy,
you measure grumpiness.
I don't know. I think grumpiness makes me do better.
If I'm just deeply irritated by the world, will my brain gauge scores change? That's actually a question I'm going to try to answer.
Well, that sounds like a good topic for an N of 1 experiment.
Oh yeah.
So this would be a great N of 1 experiment for you guys with brain gauges and smartwatches.
Yeah,
and it'd be a great crowdsource thing. We can do a multiple N of 1 experiments, and you can You can either do something like a
So
tequila shot test.
Brain gauge versus HRV.
Yeah, you can say how.
Because if they're measuring the same kinds of things, they ought to
just do something that you know will change both or one, or it's changing your brain.
Well, you could do that.
But
you'd have to have a brain gauge to do it, and you'd have to have a way to measure HRV.
Pretty much. Cool.
Okay, well, that's pretty good. Did you want to say anything else about HRV?
Well, I mean, it's just sort of like HRV is being measured because people can measure it, and I love my iPhone and all that. It's very important, but I could use a different phone if I had to. But the fact is, when there's something like that, something that you can measure, everybody wants you to measure it and talks about how important it is to measure it.
It's broadly available. People think they understand it. I'm confident there are many people who measure HRV who don't know what HRV stands for. So how much can that tell you?
Yeah.
Measuring the variability in the wrong function of the wrong organ if you're really interested in brain health, right?
Yeah, and it's actually a little bit, it's a little bit like concussion testing. I mean, there's a little bit of literature where HRV was looked at concussion testing. We're actually part of a study where HRV is one of the measures that's collected, but we won't know the results for a while in terms of brain gauge versus HRV, especially if the researcher decides to drop HRV, which they're thinking about. But anyway, it's a little bit like balance testing and concussion.
Oh yeah.
So with balance, for years people have said, sometimes when people are concussed, they lose their balance. So let's measure their balance. And so, 20 to 30% of the time that people have concussions, their balance is off. It's the loss of, they get a little bit wobbly. And the method for measuring that's pretty horrible. You can actually have the same two people scoring somebody, and you'll get a completely different score. Sort of like wearing two watches and getting completely different HRV scores. That's sort of what it reminded me of. But balance, remember, is a symptom, and it's just, but people keep talking about how important it is to measure balance in a concussion study when, it's really, it doesn't tell anything. 30%, let me just mention, how does 30% of efficacy compare to flipping a coin?
Well, that's a good question. It's sort of like...
So 50% of the time you'll get it right if somebody's concussed, but with balance testing, you'll get it right 30% of the time. Because it goes both ways. And in our studies, 3 days post-concussion, when all our scores were 30 to 50% worse than normal, balance testing showed them 15% better.
Right.
Than normal.
So this is the phenomenon we're talking about here is the popular phenomenon of being able to measure something and therefore thinking it's important, right?
Yeah.
And then there's this scientific phenomenon of thinking something's really important, pouring millions of dollars into it, talking all about how important it is, and then all of a sudden one morning somebody gets up and pretty much everybody gets up and decides, gee, that's not so important anymore. And I think that sort of happened with some of these measures. Yeah. There's a word for that. It is the grumpy science vocabulary word of the day. Let me see.
We're going to write this up.
Yeah, we're going to write it up, and it's going to take me about 15 minutes because it's a really long.
We're going to put it on this page, or
yeah, let's.
We better put it on a separate page in case we don't want to have to retitle the show.
Let's see. E-N. Let me see. I wrote it down here. A-N-T-I-O.
That's a long word.
N-T-I-O. Let me see. D-R-O-M-I-A. D-R-O-M-I-A. So there's the grumpy science vocab word of the day, which I just learned. It's enantiodromia, which is the tendency for people to have a really strong opinion one way, and then all of a sudden they kind of have an opinion 180 degrees from that. And you see this a lot. It's actually, there's a word for it, right? And you see this a lot in health research where all of a sudden everybody's like, oh, sugar is really good for you. You should use it to replace fats. And all of a sudden they're like, well, actually, not such a good idea, right? Oh, HRV, that's the thing that'll tell you everything about your health. Well, actually we've been studying it and burned a decade and a half and spent millions of dollars, and it kind of doesn't tell you anything.
Well, it's basically chasing symptoms. And so keep in mind that if you're going to measure a symptom of something, it's no difference than measuring the force of a sneeze to see if somebody's got a cold. And so
yeah, exactly.
You put it in those terms, everybody gets it.
You can measure something inaccurately, and it definitely doesn't tell you something. You can measure something accurately and precisely, and it still doesn't necessarily tell you anything. Philosophically, here's what we're talking about. Is that measurement important, and is it relevant or not? This enantiodromia word is referring to this psychological tendency that people have. And as I read about it, it seems to be the case where there are more opinions than facts. Right? So you get lots of people with lots of opinions, and they tend to polarize. And then, when there's eventually people sort of get tired of it, and then they realize it's wrong, but then they go swing to the other side. We talked about this a couple videos ago, right, where you get scientific opinions tend to be this way, right? There's this pendulum. It's like everybody believes something, and then eventually it loses favor, and secretly you can't get funding for it anymore. So they swing over to the other side,
yep.
And then everybody believes that other thing. And I believe that is a manifestation socially and scientifically of there being more opinions about something than there are facts, and that is not science. That's something else, right? That is I don't know, it's something, but it's not science. So anyway, I guess do you have anything more to say about HRV?
Nope, I just got a new word to learn.
Yeah,
it's gonna take me a while.
Enantiodromia. I just saw that one. I was like, that one's perfectly relevant, and I'm going to try to use it in a sentence. Okay, all right. I think
with
that's
a straight
it.
Face, even.
With a straight face,
yep.
and people look
all
at
right.
me, Bob, you're such a dork. All right, talk to you later.